Hope you all can hear me, and also you can see my the presentation.
Yes, Mr. Nimal,
Okay.
we can hear
Uh,
you loud and clear.
I think some of you all may have already participated in some of my past sessions. I think I have conducted about one or two sessions on this particular subject because of my interest as well as the interest raised from the SLIMA to take up this subject as a very future uh, prospectus subject. So I thought to uh, take this subject and promote it among the members. And some of you all have already uh, worked with me for a long, several times in several occasions, right? So without further time, uh, the future sustainable commodity beyond energy. Because what I think is the green hydrogen. Of course, hydrogen has a very long history in the world, in the industrial world, but the green hydrogen has a very, uh, you know, very high interest rate among industries, and also because of the climate change impact and the mitigation needs and net zero achievement needs. The the subject was well taken by the industry communities, but still there are certain gaps which we have to address both locally as well as globally. So therefore, I would like to highlight those areas during my presentation. This is basically the introduction, as I have already given in the promotional the the page as well. The green hydrogen has emerged as a critical technology in the global net zero roadmap. That's what I said. Yet its development remains limited due to comparatively high levelized cost of energy. LCOE. So this is the one of the major area which I want to discuss during this session. And conventional energy sources such as fossil fuel and nuclear continue to appear more cost competitive in traditional economic evaluation. However, these comparisons often ignore the true environmental and social cost. This is the most important thing. Some of you all, like some of our FLIMA members, who would remember the study we did, one of the very controversial study we did, the externalities of the fossil fuel-based power generation system. So there also we have taken certain studies, and we came up with certain recommendations how to take this in the cost of environment and the social and the environmental cost into this stream. Of course, there will be pollution, climate change, health impacts, and long-term waste management issues has to be costed, and then you have to add into this particular subject rather than just talking only the levelized cost or the economic aspect. Hence, this session proposed to discuss the initial avenues of the green hydrogen through a sustainability, or more correctly, a sustainomic lens beyond the levelized cost of energy approach. Uh, at this particular point, I want to give my due respect to Professor Mohan Munasinghe, who introduced this subject called sustainomic rather than the sustainable costing. This is basically a very brief introduction about the hydrogen, which I have already shared during one of my past sessions. That gives you about the basic understanding about the hydrogen. It never comes up with any word about the green hydrogen. And then production technologies for hydrogen production. These are the normally technologies we followed in this particular industrial world. The electrolysis, proton exchange membrane system, steam methane reforming, which is one of the very prominent system in producing hydrogen. Still, I am not talking about this green hydrogen. And then dark fermentation, steam reforming, and then alkaline electrolysis, autothermal reforming. Likewise, there are a series of big list of technologies which we can take into account for the hydrogen production, which I am not going to discuss each of these. However, the hydrogen production we can just list out with the type of resource material which we are using for this particular production of this particular commodity. The natural gas, propane, biomass, coal, methane, etc. we can use, and we can reform them using the carbon-based fuels, and then the otherwise we can do the electrolysis of using carbon-based electricity sources, and then we can produce hydrogen. In the meantime, we can produce the hydrogen by the way of electrolyzing the water. That is something we know from our childhood, like the single term called Vidyut Vichedana. And then some of the nuclear materials like uranium to produce heat and also the electricity. Through that path also we can produce hydrogen. So likewise, there are a number of opportunities which we can produce hydrogen. So that gives a kind of a direction for us to develop a hydrogen, the spectrum, color spectrum. Before that, these are some of the basic information about the different sources of hydrogen. Currently, nearly about 840 metric tons, or nearly around 1,000 metric tons of carbon dioxide we are releasing to the atmosphere because of the production of what you call the hydrogen. And then in this particular pie chart, you can see the resource use like the coal, or either coal or natural gas or fossil fuels, byproduct like naphtha, which we produce, especially in Sri Lanka, we were using this naphtha to produce hydrogen and then to produce what's called urea in our country. That's something which I can recall in our memories. And then again, the type of hydrogen we are producing, though the final product is hydrogen, different technologies, the type of raw material or the energy source can be different. Now, in the case of brown hydrogen, though I'm saying it's a brown hydrogen, it is not a brown color, but this is just a color type. We are using coal and then we can produce hydrogen. That particular hydrogen we can tag as brown hydrogen. And then gray hydrogen, natural gas is the major kind of, or maybe other fossil fuel byproducts like naphtha we can use to produce gray hydrogen. And then blue hydrogen, fossil fuel and carbon capture and storage technologies, because during the blue hydrogen production, there will be carbon dioxide emission. That carbon dioxide can be captured and stored. So what we are doing, there are two processes on the what you call the hydrogen production process plus the carbon capture and storage process. And the most important thing for the day is the green hydrogen. What we are doing is basically we are electrolyzing the water with the renewable energy sources. So as I mentioned earlier, this is basically the color spectrum: gray hydrogen, blue hydrogen, green, yellow, pink, aqueous, black, white, and purple. So these are the basic colors and the color spectrum or the color tags we are giving for different types of hydrogens produced with different technologies. In this particular table, you can see there are some important kind of information, the type of hydrogen which we produce through either gray or blue type of hydrogen. The second column, I have already given the feedstock and the process. And then the third column, the carbon intensity, that is basically the kilograms of carbon dioxide emitted with the production of 1 kilogram of hydrogen. And the next column is about the technology readiness level. The technology readiness level, we have given the scale from 1 to 10. So you can see the first one is the technology readiness level is about 9. It's well matured. So some of the technologies like white, the natural geological hydrogen, the TRL level is nearly about 2 to 4 like. So therefore, different technologies available, but the readiness of the technology is also at a various levels in the world, industrial world. And the next column, it has given some notes about this particular process. The most important thing, the case, is the green hydrogen. For the purpose of comparison, I have given all this data. But the green hydrogen, which we are doing with the use of renewable energy sources to electrolyze the water, and then you can see the carbon intensity is very low. So when we are talking about the need of the day, so that is climate change mitigation or the net zero approaches, definitely these are very important process. And of course, the technology readiness level is also fairly reasonable in between 7 and 9. And the most important factor is the net zero emission. It is very relevant process for the net zero process. And then you can see the last row, that talks about the biohydrogen. That is basically the biomethane production. And the biomethane, further you can go through a steam methane reforming process. And then that also indicates a very low amount of carbon dioxide emission with that particular process. That the technology readiness level is also fairly reasonable, but the life cycle analysis will show different variations, which I'm not going to discuss, but later on we can discuss, or there are a lot of references available today. The most common, the term, the levelized cost of energy. This is what we are normally using. The net present value of the total cost over lifetime over net present value of electrical energy produced over lifetime. So that is basically for the purpose of electricity or the power generation. The same kind of formula, we can derive the same thing towards hydrogen. And of course, today the levelized cost of hydrogen production is fairly high. So that's the question always we are facing. So therefore, it's a need of the day to analyze and see whether it is reasonable to consider this levelized cost of hydrogen production. Is it reasonable to use the same thing for our costing purposes? Now, here what we are trying to, here I have given another, now in Sri Lanka, if you go to the, what you call, our draft hydrogen policy, even that what they have titled is the renewable hydrogen. It's not green hydrogen. There is no very significant difference in between the renewable hydrogen and the green hydrogen. There are minor differences, but there is no any severe differences or significant differences in between these two fuels. The renewable hydrogen is commonly known as green hydrogen. Additional environmental, social, and governance criteria or grid-connected production criteria can be specified to further differentiate this particular product according to the IRENA, that is the International Renewable Energy Agency. And then when it comes to the green hydrogen is produced using the renewable energy. Of course, I have already mentioned about it. The energy sources what we are using is such as the solar or wind energy, which we can plan for it at national level, resulting in little to zero carbon emission throughout its production process. And of course, if you consider the life cycle approach, there may be substantial volume of the carbon dioxide and carbon emissions. But when you compare with the other, the gray hydrogen or the other cases, this one is fairly significantly low. This contrasts sharply with the traditional hydrogen production methods that rely on fossil fuels. As I mentioned, the gray hydrogen production, we have to rely on the fossil fuels through the process called electrolysis, right? So it's a comparatively, this one is very low. The key requirements are the crucial distinction is that the electricity must come exclusively from renewable sources to ensure the entire life cycle is virtually emission-free. Either emission-free or maybe fairly reasonably low. With excess renewable electricity, This is something which we can think about for our country. With the excess renewable electricity during the low energy demand, the green hydrogen can be produced using the electrolysis. It's practically happening if you go to the, especially the country like Germany. They are operating a Siemens plant, electrolysis system. What they do is they have a grid connected electrolysis system. And when the grid standard level, the voltage level goes up, it automatically transfers the power to this particular electrolysis, and they produce hydrogen. They store it, and then the stored hydrogen, sometimes they use with the fuel cells to convert back to power, or sometimes they take this uh, hydrogen and mix it their natural gas grid. When they mix up, they can go up to 30%. When they mix up the hydrogen, the particular green hydrogen, with the uh, natural gas, the calorific values goes up. In the same way, same time, they are increasing the cost of that particular fuel which they are delivering to users. The produced green hydrogen can be stored and later, this is what I have already mentioned. This is one area where we can think about for our country. Now, if you go to now in our country, still we don't have the facility of using natural gas for any either power generation or industrial purposes. But if you take the Sobhadanavi power plant, which they have already commissioned with diesel, is developed, made made with the use of powered with the use of natural gas. And also that particular power plant, the gas turbine has the opportunity, they have already given the opportunity or facility to mix with hydrogen up to 30%. So if we had the natural gas, definitely we could have entertained this facility to blend the natural gas and hydrogen and fire it and have a low carbon electricity. Now, question is always we are talking about, especially in our country, we are talking about the comparatively, we are talking about the battery or the pump storage. There is it's a kind of a debate in between whether to go for battery or pump storage, or we can think of either we have to consider the green hydrogen. But I have to say, grid connected green hydrogen is complementary, not competitive. The reasons are being given here. The grid connected green hydrogen production is generally not competitive with battery or pumped hydro storage as a direct substitute for typical grid balancing services. When we absorb more and more renewables, we need the grid balancing. For this one, you cannot directly compare this one and the green hydrogen process and the battery or the pump storage. Instead, these technologies are seen as complementary, each serving different needs in the energy system. The batteries and the pump hydros are more efficient for short to medium duration storage and rapid responses. It's obviously, you can understand. While hydrogen is best suited for long duration and the seasonal energy storage and for decarbonizing hard to abate industrial sectors, especially for the thermal requirements. now hard to abate industry sectors like steel or maybe glass industry. This is a very good opportunity. Or even the ceramic sector, if you consider in Sri Lanka. Uh, and then I have given some key differences and applications and the performance between battery energy storage systems and then pump hydro systems and the green hydrogen storage system. But I'm not going to go through the total spectrum of this particular table. Most importantly, for subject, that is the green hydrogen, the energy density, there is a good comparison here. Battery storage is lower per kg, and then compact volume, and then low geographically, there are limitations with the geographics. Here, the green hydrogen storages are very, of course, you may know, green hydrogen is very high in energy content. In the meantime, the primary role is being compared here, and the green hydrogen has a long-term resilience and industrial feedstock as a fuel because of its high calorific value. So therefore, it's a kind of a advantage for Sri Lanka for the replacement of our thermal or the supplying of our thermal requirements in our industry. This, of course, gives you a why still we are lagging behind the efficiency loss in the hydrogen value chain. Because whatever the case of the we are producing, when we are producing green hydrogen, we have to have a very good focus on the value chain of the hydrogen. So you can see the first process is you can see the electrolyzer, the energy content in the which we are receiving from the renewable sources, either sources, and then we have to pass it through electrolysis process. There we will have a nearly about 30% loss. And then we have to compress this hydrogen, the green hydrogen which we produce. Again, there will be another about 30% loss. Similarly, 12.3, 71, likewise, there is a huge loss of energy during this value chain, driving through the value chain. So therefore, lot of the R&D requirements still pending in the world. It's not just only to the inherent of the country or the Sri Lanka, but globally there are a lot of researches are being happening. Some of the processes they have developed are still not in the commercial scale. And then what are the current challenges? What are the current challenges? Levelized cost of green hydrogen. This is one of the most important slides. The green hydrogen is still behind fossil and nuclear power in terms of levelized cost. If you take the levelized cost of the green hydrogen and the fossil fuel base, that is basically the gray hydrogen and the pink hydrogen, you can see still green hydrogen is far behind. The levelized cost of varies significantly across different production methods and geographical locations as well, because there may be the feedstock, the that depends on the availability of the feedstock, especially the when you consider the gray hydrogen. because the gray hydrogen needs natural gas, and then natural gas availability can be a very critical factor in deciding the levelized cost of that particular thing. So therefore, little bit of inequalities will be there. So I have given some with the literature I go through. The gray hydrogen is basically 0.5 to $6 per kg, and then green hydrogen about $3 to $15 per kg, and purple hydrogen about $3 to $7 per kg. So you can see still green hydrogen is far behind in this particular case. The fossil fuel based production is the cheapest. We have to accept that, because that's how currently the hydrogen especially produced in the world. Now, if you take the case of Sri Lanka even, hope some of you all could remember, in 1970s we produced gray hydrogen using naphtha. Naphtha is a byproduct of the refinery, and then suddenly the Russian Federation, they came up with the process of natural gas steam methane reforming process. With that, what you call our urea plant, urea manufacturing plant, which we produce using the naphtha, we have to give up the whole thing and we have to close down the operation. Of course, there are a lot of other discussions we can means and the things we have to discuss. But this is not the time for that. The renewable and the nuclear pathways are currently more expensive but have high potential for cost reduction. Right? So that's what I say. In the future, there will be a lot of areas which we have to think about, which we have to take into account to reduce the levelized cost of the hydrogen production and green hydrogen production. The case is if we internalize true environmental social cost, the pollution, carbon emissions, nuclear waste management, health impacts, the long-term health impacts, then green hydrogen is not only competitive but potentially superior in the long run. So there are some basic studies I have already done, but I cannot for the moment I cannot expose this one because it's not 100% fully the calculations are not 100% accurate because of the certain data which I have obtained. But the case is, if we go with the real sustainable costing, where we can take the social and the environmental cost added into this one, definitely that one will have a very prominent or the reasonable case for the consideration. Now, this is basically a graphical illustration which shows the cost of different types of hydrogen: green hydrogen, gray hydrogen, blue hydrogen. Now, what I want to bring and discuss with you all is the green hydrogen is more than just an energy technology, but as a cross-sectoral sustainable commodity. It's like a coin. So you can see there are two sides of the coin. That is sustainability. If you consider sustainability, the key sustainability metrics like low carbon footprint, regulatory thresholds and byproducts, water use, and social and governance factors. One side you can consider. And the other side is the wide range of usage for the purposes like energy sector, transport sector, and food or agriculture sector. So that's what I say. It's a kind of so it's a sustainable commodity, but has a different value. Now, in the case of battery or the pump storage, that will connect only with the power sector. But this has a wide range of application. And then the green hydrogen, the future sustainable commodity beyond energy, if we think about the proposed key points for this argument, which we have to come up with, even in Sri Lanka or maybe regionally or maybe globally, the hidden cost of conventional energy fossil fuels like health impacts and the nuclear waste management and the connected cost and the impacts. These costs are not fully priced into today's energy market. Number one. Number two, the true value of green hydrogen that decarbonizes not only the electricity but hard to abate the sectors like the industry sector. So we have not considered these values. The enables green fertilizer production, ammonia, or reducing the reliance on fossil gases, and then they provide energy storage and the grid balancing for renewable. That is one area. And then the economic turning point cases like with carbon pricing and the stricter ESG or the ESG requirement, environment, social, and governance requirement. That also you have to take into account. The scale development, like leaving curve effects, like significant cost reduction, similar to solar PV. Those areas we have to think about. And hydrogen export potential could support the developing economies. If you consider our case, that's a very prominent area which we can think about. The social license and just transition green hydrogen projects can be tied to job creation, regional development, and energy security. Moving early ensures the leadership in future global commodity market. If we consider that sort of case for the Southeast Asian region, Sri Lanka has a very good high potential. So therefore, beyond the LCOE, which we have to focus through a Sustainalytics that needs in thinking beyond the incomplete traditional costing with the total life cycle approach. And the Sustainalytics is about integrating the economic, social, and social development and environmental sustainability into decision making rather than treating them separately. So we must apply the Sustainalytics framework to properly value the green hydrogen as a cross-sectoral commodity beyond the narrow metrics of levelized cost. That fits perfectly with moving beyond narrow sustainable costing or levelized cost to a holistic valuation framework. So here I have given the economic values and the social values and the environmental values of this sustainable or Sustainalytics perspective. Again, my great respect to the Professor Mohan Munasinghe, who came up with this Sustainalytics concept. But I don't know whether this particular word still is in the global cases like global dictionaries. But of course, we can think about through a sustainable development framework. And the points which we have to bring into the debate: should environmental and social externalities will be fully integrated into lowest cost of energy calculation for fair comparison? Is green hydrogen the missing link in achieving global net zero? Well, we are very seriously globally with the Paris Agreement. We are talking about the global net zero, but still we are forget to discuss about the sustainability approach in this particular case. How can global governance, either UN, World Trade Organization, World Bank, like organization, ensure the equitable access to hydrogen technology for developing nations? It's not only for the developed countries. Of course, with the developing nations, we have to preserve our histories. The green hydrogen becomes the green oil of the future, traded globally as a sustainable commodity. So these are some of the very important debating points which we have to bring into our tables. Even in Sri Lanka, we have to start thinking through our professional networks. And hydrogen as a commodity beyond energy, that's what I say. As an energy vector, we can think of when there is an excess amount of electricity, we can think of it as it's not a source of energy, but it's considered as an energy vector. Uh, building and building heat and cool, fertilizer industry, industrial needs, steel, glass, ceramic, etc. Of course, ceramic industry needs is a very crucial need for Sri Lanka. And then the chemical industry, of course, mobility, like marine aviation fuel, as a marine and aviation fuel. And then heavy duty vehicles, and then long-term haulage, we can consider as a very reasonable fuel. This is the same thing which I have already given in my previous slide. I have put it into, I have brought into a diagram, which was a kind of a resource I have taken from the UNDP publication. Therefore, we have a call for action, need in launching a structured debate on this theme at international business and the policy platform by applying Sustainalytics. The conversation around green hydrogen can shift from cost limitations to its fully sustainability value, opening pathways for investment, innovation, and the global cooperation. These are some of the key aspects of the national roadmap, which I have gone through. I'm not going to go through it in detail, but you can download this document from the our Energy Ministry website. In conclusion, whether green hydrogen becomes a tool for prosperity or a source of further socio-economic pressure and conflict lies in the hands of the policymakers. Navigating this journey is a test of governance and a defining moment in the pursuit of global sustainability. So we are very seriously talking about global sustainability today. So therefore, it's a high time for us to even think locally about this particular subject, green hydrogen, whether continually we have to, because we are trying to go behind the what you call SDGs. We are talking about very seriously about SDGs. But if you take the values of the or the KPIs of the SDGs into this green hydrogen subject, definitely that will have a very real value. So that's something which I can share with you all. Of course, if there are any relevant questions, definitely we will be able to discuss it. Thank you very much.
Yes, thank you, Mr. Nimal Pereira, for the very insightful presentation on that current topic. So, and I'm sure the audience too will have interesting questions to pose at you. So next we will have the Q&A session, which will be moderated by Dr. Migara Liyanage, our Joint Secretary. Dr. Migara, the floor is on you, sir.
Okay, thank you very much, Nimashi, and thank you very much, Mr. Pereira, for that insightful presentation. I think you presented a lot of interesting things and how it is new source like green hydrogen will be useful for Sri Lanka. And I think that in spite of this bad weather, I think today we have a number of participants, and I would like to thank them also for being here with us today. And to begin the discussion, so before I start the Q&A, I would like to request other participants to forward their questions so that we can have a very meaningful discussion here. So let me start with the first question. Where the question is, I am from the maritime industry in Sri Lanka. I would like to know your views on the use of green hydrogen as a fuel for ships, the current international fuel cost situation, and the challenges Sri Lanka may face in fuel bunkering. So that's the first question.
Yeah, the future will be especially connected with the green hydrogen is green ammonia. Especially for the shipping industry, the maritime industry, what they are planning is to use the liquid ammonia for this particular purpose. And then that particular ammonia will be, liquid ammonia will be the manufactured or processed with the use of green hydrogen produced from different countries. According to the earlier plans, there were some plans in Sri Lanka even. They use the Sri Lanka as one of the maritime hubs to dispense the green ammonia, which produced in with the collaboration of India and Sri Lanka. But I don't know whether now they have this particular concern to use anyway the future will be the use of green ammonia as a fuel for maritime purposes. There will be and even there was a case I could remember. Now we have this tank farm in Trincomalee. There were some discussions about this particular tank farm to use as a use for the purpose of bunkering green ammonia. So there are certain discussions. Of course, with the especially with the this 2050 net zero achievement, those things will be definitely come up. So that's something which I can share with you.
So I think before we proceed with the next question, I would like to ask you a question about the cost that you showed us about this green hydrogen. For something to be really be used in as a fuel, it should be cost effective. So when people try to buy a product, they think about the cost involved. So as you said, the cost of green hydrogen is between $3 to $15 per kilogram. Now, this is considering all, first I would like to know whether it is considering all the cost components involved, or was it cost using the Sustainalytics principles? And now if say if I take a value like say $10 per kilogram now, considering the amount of kilowatt hours available for available in 1 kilogram of green hydrogen, a unit of electricity will cost around 90 rupees
Yeah.
at the current costing. So, can you comment on the pricing? And also, at the very beginning, I think if you consider even solar, the costs were very high, and no one thought that it will drop to the rates today. So, that is how these technologies evolve. So, would you like to comment on that, please?
Yeah, Dr. Migara, you could remember what was the cost of the renewable electricity, especially the solar-based electricity, maybe about 10 years back. And what is today? So similarly, now it's very drastically it's coming down, maybe because of because of several reasons. Maybe the technological changes, or maybe the involvement of major investments like countries like China. So because of those cases, actually the cost is coming down. And similarly, the one of the major reason for this the high cost of green hydrogen is the cost of solar. So therefore, this one is drastically reducing with the introduction of new technologies. Of course, every day I can see the new technologies are coming up at lab scales. And also certain cases now they are converting to the commercial scales as well. So therefore, I am sure it will be like the solar industry, the solar electricity industry. This one also will start going down very soon. But for that, the adding the essence of the sustainomics will be a different case.
So, thank you, Mr. Pereira, for your reply. The next question is, a few years back, hydrogen and batteries were competing technologies for energy storage. But with the recent reduction in battery cost, has hydrogen lost the race? Is there a chance for hydrogen to perform better than batteries in some aspects, such as mobility or industrial thermal applications?
Of course, there will be. That's what I say. It's not the competitiveness and the that case gives a kind of a response for this particular question. Competitiveness and the complementariness. So therefore, the competitiveness in the case of this one, what I feel is that's what I have already mentioned in my slide. It should be a complementary. It will not be the competing with each other. Because now, for the total picture of the national hydrogen system, national energy system, if you take, I am not going to propose fully supported with the either battery technologies or pump storages, but there should be a kind of a complementary nature from the other cases. Depends on the economics, or more widely with the sustainomic costing. Definitely we can decide which one would be the most relevant, and then we can decide how we can propose a system or a full picture for the country with the complementary support.
So I would also like to now any other questions, please. So I think Mr. Parakrama Jayasingh has forwarded the question. What is the current minimum scale of hydrogen production vulnerable for Sri Lanka for use to replace fossil fuels for thermal energy in industries, say ceramics?
What is the current minimum scale of hydrogen production? Mm,
For to replace fossil fuels for
Thermal energy
replacing thermal
industry.
energy in
Yes,
ceramic
yes, yes.
industry.
Still, this is in the case is not, because we have not taken any project about the process, but certain what you call the studies are being in the process. Not, I cannot give you the fixed figure or the confirmed figure for the moment, but when I had a discussion with especially the ceramic sector, some of the ceramic producers, they are showing some kind of a interest on this particular the topic. Not initially to have a full-scale replacement of thermal sources with hydrogen, but it will be basically like partial replacement, like maybe blending with, because most of the ceramic industries now they are using LPG. The potential of blending LPG with hydrogen is much more less than the what you call natural gas. Natural gas, of course, you can go up to the 30 or even 40%. But in the case of the LPG, still the blending at commercial level, still what I found is only about nearly about 10 to 15%. There are certain technical reasons, but those cases will be sorted out very soon with the certain research and development activities in the world. But one thing is, now the gas turbine what we have is in our Sabardhana is can go up to 30%. It's a F-class turbine. You can go up to 30% blending with hydrogen. But according to the sources from Siemens, what I heard is now they have come up with 100% hydrogen based gas turbines are commercially available. So therefore, of course, for the thermal energy based power generation, it's a good sign. The only thing is the production side, production of green hydrogen with various other sources like the renewable energy sources will be the only case. For that also there are a lot of research and development activities are in pipeline. What I understood was nearly about by 2030, most of these cost factors will be sorted out, and it will be those will be competitive with the other gray hydrogen or blue hydrogen cases. But before that, if you consider these astronomic approaches, definitely it will be win the race before 2030.
So thank you very much, Mr. Pereira. Any other questions from the audience? So we might have time for one last question.
And again, one
So,
thing I want to propose to Slima. Now,
yeah,
this is a good area for Slima to take it out. And
yeah,
maybe developing, maybe working with global agencies. That's why I have already had a kind of a small working group
yes,
developed at the very beginning, I think about 3 or 4 years back, uh, with the support, with the leadership of Professor Atalagi. We have developed a kind of a small working group to strengthen this particular, making this particular group further strengthened,
yeah,
and take more and more research areas with the global agencies like UNDP, UNIDO, or maybe other commercial agencies, even like the Linde. They are ready to. They are ready to work with the professional groups like Naslima.
yeah.
So I think this is a good opportunity to consider and take this one into consideration.
Uh, Thank you, Mr. Pereira. I think that definitely it has a lot of avenues and lot of opportunities for Slima. I think you initiated the working group and we have done some initial work as well. So I think there is one question from Vikramaratna. So he can ask his question. Anyway, so I think he is not here.
I don't know,
So
Vikramaratna, big Vikramaratna, Charles Vikramaratna, or any other.
I
There
think
are a
it's
couple of Vikramaratnas in the.
yeah. But he has suddenly he was here. Maybe he has got gone offline. Now, my last question. I think so. Any other questions from the audience? So before we wind up now, what will be the starting point for Sri Lanka for something like this? This is a new area, new fuel, and there will be a lot of opportunities for a country which has very rich renewable energy resources. So what will be the starting point for a country like Sri Lanka?
I think the best person to be to answer this question is our friend Mr. Harsha Vikramasinghe. I don't know whether he's there because CA has already developed, or maybe um, the somebody else from the CA. If they
Yeah.
are there, they can come up with the best answer for it. I think they have already came up with the policy because we need a policy development. They have gone for the development, they have gone up to the draft policy. It is available for public comments. And then I think the private group has came up with roadmap as well. So with all these things, I think there are, and also the good thing is I heard during the budget speech, there were some commitment from the government to take this one into account for as a future need. That's a good sign. So with all these things, I think there will be a good momentum there. That's what I would see. Especially for the young generation, I think this one will be a good areas for R&D and various considerations.
So with that, I think we have to wind up. So anyway, thank you very much, Mr. Nimal Pereira, for that very insightful session. It was a very interesting presentation. Unfortunately, the day today is a very, we are having a very severe weather situation. So even with that, we had a very good participation. So I would like to thank all those who participated in spite of all the issues that you have. So I would like to hand over the floor to Ms. Nimashi Fernando once again.
Yes, thank you once again, Mr. Pereira, for fielding the questions, and Dr. Migara for moderating the session well. So, audience, we hope to see you at another insightful webinar soon. And until then, good night, and also stay safe from this bad weather. Good night.